let's see some practical example of orthogonal projection. If we want to find the orthogonal projection of any given line on any definite straight line, in that case just imagine one light source here. Then the shadow of this line on this definite straight line will be the orthogonal projection of this line. This one is the orthogonal projection of this given line. That is, we can say this orthogonal projection is the shadow of this line. Welcome to AMIRS Math School. In this video, we are going to learn about the orthogonal projection. And the discussion point about this orthogonal projection in this video are the basic concept, and then some explanation about the orthogonal projection, and then finally the practical example of orthogonal projection. Let's start. The orthogonal projection of any line on any definite straight line is the length between the foot of perpendicular drawn from the initial and the terminal point of that line. That is, if we consider this AB is any line and this EF is the definite straight line where we want to find the orthogonal projection. To get the orthogonal projection of AB, we have to draw the perpendicular from the initial and the terminal point and identify the foot of perpendicular. This one is the foot of perpendicular drawn from the initial point, and this one will be the foot of perpendicular drawn on the terminal point. This length will be the orthogonal projection of the line AB. Consider this length is indicated by this line. So this line is the orthogonal projection of this AB. This one is our line AB, and we want to find the orthogonal projection of AB on this line. So we have to draw the perpendicular from the initial point and find the foot of perpendicular, and also the perpendicular at the terminal point and the foot of perpendicular. So this length will be the orthogonal projection of this line AB. And if we just replace this line here, in that case this line makes an angle with the original given line AB. Suppose this angle is theta and this point is C. So we get right angle triangle, that is ABC, where this angle is theta. Now, and in triangle ABC, we know BC divided by AB, that is base by hypotenuse, is equal to cos theta. So we can write this BC is equal to AB cos theta. So we just write here, in case of BC, we can write this one be AB cos theta. Since this value is the length, that's why we just use here the absolute value sign. Now we know the value of cos theta is vary from 0 to 1. If we take the absolute value, that is, the minimum value of the absolute value of cos theta is 0 and the maximum value is 1. So from here we get the value of BC, which is the orthogonal projection of this line AB. That is, the maximum value of cos theta is 1. So the maximum value of the orthogonal projection of this line AB will be just AB, because the cos theta value is 1. And what will be the minimum value? The minimum value of the absolute value of cos theta is 0. So the minimum value of the orthogonal projection of this line AB will be 0. So from here we can say that the maximum value of the orthogonal projection of any line will be exactly equal to that line, and the minimum value will be 0. Now let's see some cases of orthogonal projection. That is, first one, when the given line is parallel to the definite straight line where we want to find the orthogonal projection. That is, when theta is equal to 0 degree. When theta is equal to 0 degree, if we draw the perpendicular from the initial and the terminal line, in that case we get the orthogonal projection. And in this case, this orthogonal projection of AB, which is equal to CD, which will be exactly equal to the line AB. So we can say when both the lines are parallel, then the given line and the orthogonal projection will be equal. In this case, we can get the maximum value of the orthogonal projection. And in case of any rotation, that is any oblique position of any given line, we get the value of orthogonal projection is less than the given line. That is, for any rotation between 0 to 90 degree, we get the orthogonal projection which is less than the original one. Just consider some rotation of this given line AB. In this case, if we draw the perpendicular from the initial and the terminal line, we get the value of orthogonal projection which will be the less than the original one. So in case of the rotation of 0 to 90 degree, we get the value of orthogonal projection which is less than the original one. And finally, when the given line is perpendicular, that is the value of theta is 90 degree, in that case we will get the value of orthogonal projection, that is the minimum value, which will be 0. That is, in case of perpendicular line, the orthogonal projection is 0. Here, the foot of perpendicular is just a point which have no length. That's why the value of orthogonal projection is 0. In this case, this orthogonal projection of any given line is the minimum length, that is 0. Let's see some practical example of orthogonal projection. If we want to find the orthogonal projection of any given line on any definite straight line, in that case just imagine one light source here. Then the shadow of this line on this definite straight line will be the orthogonal projection of this line. This one is the orthogonal projection of this given line. That is, we can say this orthogonal projection is the shadow of this line. Again, let's see another example. In this case also, if we consider here one light source, in that case this length will be the shadow of this line on this definite straight line, which will be the orthogonal projection of this line on this line. Next, consider one perpendicular line. In that case, if we consider here one light source, then the shadow of this line will be just a point which have no length. In this case, this orthogonal projection will be the minimum length, that is the length 0. That is just only one point. Again, let's consider this curved line. If we consider here one light source, in that case the shadow of this line will be just a straight line which have this length. If this curve is along y-axis, in that case the shadow of this line will be just a straight line, this length. The orthogonal projection of this curved line will be this line, which is the shadow of this line. Again, if we want to find the orthogonal projection of this circle on this straight line, where this one is the diameter of circle, in that case consider here the light source, then the shadow of this circle will be just a straight line which is equal length of this diameter. So in this case the orthogonal projection of this circle will be just a straight line. Let's consider one square in this position. Here this one is the diagonal. So in this case the orthogonal projection will be this length, that is a one straight line which is equal length of this diagonal. Again, consider this type of shape, and in that case the shadow must be a straight line which length is this one. So this is the orthogonal projection of this type of shape. Finally, this pentagon, this one is the length between two vertex. In this case also the orthogonal projection will be just a length which is equal to this one.